Hi everyone, this video is going to be about a project crop oracle. We're going to show you the requirements given to us by the client as well as the quality of our project. So the user stories presented to us for this project, we have that of agronomists. So basically they would like a front-end web interface for them to be able to view the spectral imagery with different vegetation index types, have some information such as area and size, as well as be able to adjust these areas as well as creating their own areas. Another user story perspective is that from a farmer. So they would like to be able to change the threshold to view different kinds of anomalies, have a very friendly user-friendly interface, and also be able to draw their own anomalies. As for the progress of our projects, as you can see in this graph here, over the weeks we have increasing number of functions being implemented, as well as a decreasing amount of functions being unfinished. The jump in the middle there with our unfinished implements is as the client started adding more requirements to our project. And for this graph here, you can see the overall decreasing amount of bugs and issues in our project. So obviously in the beginning, we have very few issues as we have very few implementations. As implementations grew, our issues grew, and as we headed further down the line, our issues and bugs began to reduce as we started to increase the quality of our project. As for client interaction, we use numerous technologies. The main one being GitHub to share our code, so the client could ensure that we met their requirements as well as maintain the quality of our project. And for face-to-face online interviews, we use Zoom. So we also conducted a usability survey for our usability testing. We got our client as well as a group of friends to test the usability of our project as well as give some feedback. So as you can see, in our first iteration in week 6, most of the people consider our project to be neutral. In week 9, a lot more people started being satisfied with our project. And in week 12, the majority of all participants said our project was satisfactory. So as you can see, this is our project. You can select the field. In this case, we're going to select field 11. So in each field, you have some summary of information. So we have the area, we have the index type, and we have the crop type. We are able to select the type of index, so we can select M-Savvy here, or NDRE, or NDVI. These are all different index types, and with each index types, you get new anomalies depending on the anomaly areas. So here, for each of these anomalies, they're outlined in a blue line. We also have a pin marker for the user to be able to clearly see these markers. We also have a summary table. Each of these anomalies will have some summary about the area, their mean index, and what kind of issue they have. So yeah, so when you click on each row, the color of the pin of the corresponding anomaly changes color. And another thing we can do, for the user can do, is adjust the slider. This will change the threshold of the algorithm in the backend. When they change it, they click filters again. This will change the type of and size of anomaly areas. And as you can see, they're not going to be satisfied with these areas, so they can also construct their own anomaly areas using a polygon drawing tool. So after this polygon drawing tool is drawn, is also added to table, and also on this table they can also add what type of issue they have for each anomaly areas. More detail can also be about these anomalies can be defined by in the top drop-down table, selecting each anomaly. They can also add extra information for each anomaly. As you can see, so they can customize their own information if there's some interesting factors about the anomaly. After drawing an anomaly, the user can save this anomaly. This will show a pop-up which tells you the anomaly area has been saved. And this new anomaly will also be added to the summary table. As you can see there, it's at the bottom, anomaly 9, and the corresponding pin highlights up. After all this, the user can also download the KML file. And this KML file can be used in other apps such as Google Earth. I can then import this file from our website, and it will snap onto the corresponding area on Google Earth. As you can see, these areas here match our own anomaly areas, including the user-created anomaly area. And that's it. Thank you. You have a lot to cut in there.